This video covers section 12.3, Parabolas, Objective 1, Graph parabolas whose vertex is the origin. So we know what parabolas look like. They open up if a is greater than 0, and they open down if a is less than 0. And if it's written in this shifted form, the opposite of positive 8, which is negative 8, and the negative 9 is where our vertex is. We go to that spot on the xy plane, negative 8, negative 9, and we have a negative 4 in front, so the graph opens downward, and we can sketch the graph pretty quickly from there. So the summary, we know that opens up if a is greater than 0, down if a is less than 0. The vertex h comma k, we know we can use the formula negative b over 2a to find it, and plug it back in to find the y coordinate. So that's just a real quick review of parabolas. Now remember, a parabola arises from a conic section. A parabola arises when you take a section of the cone where your section has an angle smaller than the angle of the cone, and you'll section it off, and the intersection of the cone is going to be the parabola. The definition of a parabola is all of the points P in the plane that are the same distance from a fixed point F as they are from some fixed line D, called the directrix. The point F is called the focus of the parabola, and the line D is called the directrix. So if we can find points that are equal distance from F and D, then we've got points on the parabola. So the easiest one to do is to go halfway between F and the line D, and there's your first point on there. The next point would be, if I go out some distance, then I'm looking for the point that has the same distance to the line D, and there's that point. We have the same one on the other side, that point. Or we go out here and that same distance, and we start forming these points, and we get all the points on the parabola. Every point on this parabola is going to have the same distance to F as it does to D. So remember, we've got the distance formula. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to take the distance between the point P on the graph and the directrix D. So the directrix D has this point negative a y on it because the point P is at xy, and it has this point A 0 on it. So if this is A, this is A. So the distance from P to the point D on the directrix is going to be x minus a minus A squared plus y minus y squared, and then the square root of that. And now the distance from the focus to the point is x minus a squared plus y minus 0 squared. Square root of that. Now if we square both sides, those square roots go, and we have x plus a squared plus y minus y is 0 squared is 0, so that's gone. And on the right side, we've got x minus a squared plus y minus 0 squared, that's y squared. When we square the x plus a, we get x squared plus 2ax plus a squared. When we square the x minus a, we get x squared minus 2ax plus a squared plus y squared. Now, these x squareds cancel each other out. This becomes 4ax when I add 2ax to both sides. The a squareds cancel out, and I'm left with y squared. There is the equation of a parabola. Sorry, that's an ax. Whose vertex is at the origin. That opens to the right. The focus is a units away from the vertex. The directrix is this vertical line, x equals negative a. We have 4 types of parabolas now. We have the parabolas that open right and left, and they all look like y squared equals. We have the parabolas that open up and down, and those are the x squared equals. Remember, we know the base parabola y equals x squared. This opens upward, so when the x is squared, it's up. If the x has a negative in front of it, it's down. Now we're looking at what to do if the y is squared. This opens to the right, and if it's negative, it opens to the left. Notice that the focal axis is this axis right here, and it always will have length of 4a. And we'll see that throughout this. So here's an equation. We want to plot the focus and 2 other points on the graph. Y squared equals 8x. We know when the y is squared and the x is not, the graph opens to the right. The vertex is at the origin. We're going to match this up with the form y squared equals 4ax. Because remember, the focus is always a units from the vertex. So what we have is y squared equals 8x. And so if I take 8 and set it equal to 4a, because that's what we need, 4a is in front of x, 8 is in front of x, this says that a is 2. So we have y squared equals 4 times 2 times x. And once you know your a, you know where your focus lies. The focus is 2 units from the vertex. The parabola opens to the right, so it's at 2, 0. The directrix is 2 units on the other side. Now, I know the parabola opens up something like this, but I want to get those 2 other points on the graph. And here's how you find those 2 other points. You always go to the point where x is equal to where the focus lies. So we're going to plug in x equals 2. And this is going to show us that our focal length is always this 4a or 8. So watch this. We plug in x equals 2. We have y squared equals 8 times 2, or y squared equals 16. That tells us that y is equal to plus or minus 4. These are the 2 points on the graph, 2, 4 and 2, negative 4. Let's see how I did. 1, 2, 3. Oh my gosh, I almost got that perfect there. 1, 2, 3, and 4. I was very lucky when I did that. So that was a very accurate sketch of the graph just by freehanding it. And the focal length is this line segment from one point through the focus down to the other point. And that focal length is 8 or 4a. That will always help you get your other 2 points on the graph. Here's a practice problem for you to try. Make sure you go back up to your table to figure out left, right, up, down by the form of it. The x is squared and the y isn't, and the negative's there. I encourage you to press pause on your video and work this out, and come back when you're ready to see the solution. Now that you've had your chance to work this out, I'll work this out with you. I always start off by remembering that my y equals x squared is my traditional parabola that I'm used to, and it opens up. If it's negative x squared, then it opens down. And this is the form that we have. We have the x squared and the y isn't. Because it's negative, I know my graph is going to open downward. Now I'm matching this with x squared equals 4ax. This means my negative 12 equals 4a, or a is equal to negative 3. My vertex is at the origin. My focus is 3 units down from that, 1, 2, and 3. The graph opens on the focus. But now I want to see if I made the right kind of opening. Is it wide? Is it narrow? That depends on A. Remember that your focal length here is always 4A, which is going to be this 12. And we see why, because we're going to let this time Y be equal to the Y value on the focus. I let Y be negative 3. And when I do that, I get x squared is equal to negative 12 times negative 3, which is 36. And x is equal to plus or minus the square root of 36, which is 6. That tells us our 2 points on the graph are 6, negative 3, and negative 6, negative 3. So we go over to 1, 2, 3, 4, 5, 6, negative 3, and negative 6, 2, 3, 4, 5, 6, negative 3. That dictates how wide this parabola is. This concludes the video for section 12.3, Parabolas, Objective 1, Graph parabolas whose vertex is the origin.